make sure I can see everything, because I know students will be like, what do I do? And I can't just take pictures of what it is. They have to see all the steps. So I'm going to try to position it like this. You get the calculators to hold it. All right, so there we go. All right, so here's what you do, right? Got this ruler over here. Look at a yardstick or something. Oh, yeah, so that's the things over here. Stopwatch and period tape. We're going to talk about what those do. So take the ruler, right? You want to measure it from the axis point, right? I don't want it on top of the pendulum. I just want it here so I can see what's going on with it. I'm trying to match it from here to here to get a measure of how long the string is that's holding the pendulum in place, right? And if you look over here, I did that because I want to match the pattern over here. If that's 0.7 meters, it's about the same there. You convert your centimeters. So centimeters is -2, so this is 70, you move it over twice. We did that conversion. We was in the CD player, right? And then on top of that, the more you give more mass, the heavier it is, the more it will swing.
Why? This one in the program, it ain't got nothing nowhere. So I put no serial numbers. You ain't got that many, but one of them didn't have
1.25.
One of them didn't have no number at all.
Okay. Gravity, first screenshot we're going to see on Earth. Okay. Just give it a little bit of friction. So about 2 notches. We're going to start with nuts to 2 notches. And we have a little stopwatch over here. Now the goal is to hit pause before you start swimming. You don't have time to start the stopwatch and start the swim. So let's hit pause for a second. And let's see what happens right here, right? We're going to drag this to about, I want to say 90 degrees. So if you're not sure, you can put the ruler over here. I don't know if you saw it, but this is the degrees. So let's say I'll use a degree symbol, right? So we're going to go 90 here. So I'm going to go here. The sad part is I got to match it back up, right? So make sure if you move the ruler around, make sure you match it back up. Starting with the axis point, and let's line here. Okay, so put it on this side so you see the angle of 90 degrees. Now, flip back, 90. Right here. And the next thing is, of course, we hit the stopwatch after we hit the play button. Maybe quick too. You hit play and stopwatch, and it's on. Now look at the period trace, right? So a period is 1 revolution per back. It disappears. Full revolution would be a whole circle, but it has to come here, and then return. So like here, there, return, that's 1 period to see go away. So try to capture it and have a full period. Meaning, 1 here, when it starts, it goes this way. As soon as it is here, you get a screenshot to see the movie before it disappears. Okay? You know you're ready for sex ratio. You capture the full period return. Alright, so how you go with screenshot? You got 2 edges. You click down here. This is kind of cool. You click down here. It's kind of hard. It's tiny, right? You click down here. As soon as you got a revolution, you get a screenshot, or you can press the print screen button. You choose what you want. Yeah, this one might take some time to capture, right? You got, as soon as it makes a revolution back, I pop. Right? Or as soon as it makes a revolution back, you got your full period in blue there. You can get the print screen up. You got it quick. You know. You got it? Okay, I'll put it in your eye section. Alright, we got one more to do. We're going to take it away from Earth, and we're also going to put 2 pendulums. And we're going to try to capture a period as best as possible. Not really capture half the period, but you try to see what happens with both of the periods. So go ahead and click on this one here. You And you got two pendulums now. You leave a ruler there. We're going to hit pause, right? You want to slow things down. That's another way you can take a straight shot. I tell you, you hit the pause button. You might need to in this situation. So I'll get there, then take a straight shot. So you got what you want. So you got to be tricky with this because, one, we're going to put some mass on, this is not a lot of mass on number two. So put a little more mass on it because you want to swing almost the same revolution. So we're going to take it down by, take it to 1 kilogram, now it goes to 1.3 kilograms. Right? The length, we want the length to be about a little more than the other ones. I want you to see how that changes with the swing. The shorter the string, is it going to change if it's a longer string? We're going to see, right? Let's reset our clock. Whatever you took that first screenshot, it should have been how long it took you to do it. Because I want to see how long it took you to get it. We're going to go this time in slow motion because maybe it'll help you capture the periods. So the first time you saw it, this is the period, right? On this way, return. Basically, it's blue. This one's going to copy you red. Copy is. So, as long as you have the rules set the same way, the measurements will be the same because you notice the left is total of 1 meter, where it says 90 centimeters. So, it should be about 1. We're going to drag this pendulum back to 90 degrees. Okay. And now, the other pendulum, we're going to take it to negative 90 degrees. So, it's going to be tricky because you can't see around this ruler. So, if you move the ruler, that's fine. But that's about 90. And you know about 90, you can't see the little red negative 90. This is like right at the beginning of this upside down protractor. Right? All right, what else do we have? I told you we're not going to stay on Earth this time, right? That's called gravity and it pulls everything down. So we're going to click here. We got other planets we can go to. We're going to try out Jupiter. You know what? Let's do the moon. Okay? That's closest to us. You know, people jump around the moon. Notice the gravity itself is down. So a lot of times we watch old space. Recordings of astronauts jumping around. They jump a little bit, but they right here a little longer until they pull down by force. All right, so what do we got? If we're all straight, what we're going to do is we're going to, like I said, we're going to hit play. We're going to hurry up and press our stopwatch. Hit play, stopwatch, and you'll see everything happen. Notice the traces for each period is there. Your goal is, you know, you might want to click on slow-mo, that helps. As I told you, is to capture both periods before they disappear. Try to capture the blue screenshot. So you kind of got to watch when one starts. Red started before the blue. So what happens if we extend the screen? Notice the blue is trying to catch up because it's short. So here we go. We got to trace it back. I'll put it in slow motion so I can really capture it at the right time. If you hit pause and you think you got it just right. So, catching up. Looks like we're going to have to pause it before red completes its period. We're going to lose both, right? So, here we go. Okay. We're going fast to get ahead, right? Just coming back. And notice it's not at 90 anymore. So each time it spins, it doesn't get quite close to the original setting. So almost there. And I think about at the top, the blue's about to fade out. We have both. Take a screenshot if you can. Just do 15 seconds. So you let me know you're ready and we'll start the video. This camera here. Because I know she would be like, I don't know what to do. You know, I do. Watch the video. Alright, so I'm going to run through this problem for all of the kitties that couldn't make it in the snow. Where's my markers? I got red and purple, okay? Now, let's see, I gotta get a book on it. Now, are you done with the screen, Mariah? Can I change it? Okay. So, if we look here, try to get my mouse to come over. We have this situation, right?
I'm going to go ahead and read it for you because I know you're getting tired of reading probably. And it's only because we technically supposed to review this 3 times. CPS teacher speak or teacher tactic. So, class determinant is angular acceleration. We'll talk about that in our review problem. And you'll see a lot in the reviews. Where they diverse, use freestyle or whatever, but that's actually what it's characterized as used. And as soon as be able to synthesize algebraic conversion techniques using their prior knowledge of rotational motion and equilibrium to complete quiz 0 as opposed to 1. If you're a scientist, you start with 0. Scientist mathematician, you don't start with 1. It's actually the correct way to do it, but it is what it is, most people. So let's go ahead and knock this out. Desire. I'm gonna now click on this. And do you want to read that for 10 or you want me to just read and do the problem? It's up to you. You're looking real hard at it. Which one is it? You say you don't want to read? Okay. All right, go ahead. You got to speak up because that mask, I'll be looking at you sideways. Or pull the mask down for a second, something. Rotating. There you go. Constant, sweetie, constant. You got it. It's SAT words. I'm just helping. I'm not trying to pick on you. You got it, yep. All right, you got it. So give yourself 10 extra. Now this one uses some algebra. It's not cut dry, right? And I think we did something like this yesterday, I think. But we're gonna see what happens today, right? So let's go ahead and there was a hint on 274. So if you don't remember from yesterday how everything went down, you could use your notes, right? You could probably bring those notes over because this is a similar problem. So 274. So where we at? So last time you got the equation, right? With alpha in there and stuff. So if you don't, it's on 274, that box in green. Okay. So let's write it out. This is your redo. And I'll put a picture online too again. But it's similar, I just changed the numbers. If you have the notes, you might have all this really done and you can really smash. But I'm gonna go through the problem because that's what I'm supposed to do. And there probably are some students that didn't even take the notes down from yesterday. So again, we're dealing with Greek letters in here, and everywhere you have it, and I'm not speaking to you specifically, Mariah, because I've seen some of your work. You are putting the Greek letters in, so thank you. I'm just saying it because it's recording, and I want students to know that's important. You can't cut corners with these Greek letters. They're mathematical applications. So, with that said, you have average angular acceleration, right? Angular acceleration. And it's written as shown on page 274. That's alpha, right? It's a Greek letter, AV. That's what I'm writing. You can look in the book. Is equal to, we have this situation. I'm going to write it better this time. You got delta omega, it's not a W, over delta T, right? Now, the thing with yesterday's problem and today as well is delta, it means final minus initial, or another way to say it is change in. Some people, if they're real, scientific or jazzy with it, they would say displacement, right? Kind of like displacement of water. So this is delta. That's how you find that Greek letter. And when you write this out, it's a little bit more to it. So you can say delta is also known as, before I get there, omega final, like we did yesterday, minus initial over delta T. And you could say this is, what we're trying to say, TF minus TI, because that's what the delta means, right? We have these two, well, they're both measured, even this one over here. Right? You don't have to write the arrows because it's like you're supposed to have that from the box. But basically, all of these are forms of either rads per second. We talked about that yesterday when we look at our graphs. Or you can discuss this in terms of RPMs, right? So this one is more degree related, like in how many degrees. This is more, oh wow, she made it. You need a laptop too. Give me a second. Some of y'all like warriors, y'all made it. A lot of people mark action. See that works great.
Those computers up there, those are different than these.
Yeah, these are Dell's. Those are, say, 4 robotics laptops, IBMs, and mostly Chromebooks. All right, so what was I saying? We're gonna, when you get a chance, Ms. Booker, we're already on the We Do, and you can find out from Mariah how to do the I Do and stuff. When you get a chance. You got a problem? Huh? To the laptop? Oh, okay, you found it. Okay. All right, so what was I saying? Now, these, of course, down here, I mean, this is the same as that, not triangle thingy, but it's the same, like I said, as the above symbol. Time, on the other hand, T is always measured in seconds, and your average angular acceleration, well, it just basically depends on when you're calculating it, right? So it's going to be rads per second squared, right? Be careful with that because some students will be trying to square the number. No, the only thing squared is the dimension in the bottom. So you write that as rads per second squared, right? It's not, that doesn't mean you square the number. Some students are trying to do that. Don't do that. That's just, it means it's an acceleration, kind of like meters per second squared, right? So we're going to box this off, and this is the first part of your notes. Like I said, it's listed. You don't have to do what I did. I'm doing this so I can make sure you understand how to pick the problem apart. What you need for these notes in part 1 of your notes is just 274, that green box, right? You don't have to write everything with the arrows and get creative like me. That's all you need. So I forgot to mention that this W here, it is known as omega. If you're looking for that Greek letter, if you have a W written into your document, I'm going to take points away. This thing, before I forget, is also alpha. It's like a sideways half of 8, right? So alpha is a Greek letter as well. Now we're ready to find out what the ingredients in the problem are so we can take it apart and cook it or prepare it for getting done. So known values, what do we know, right? Versus unknown. What is the question asking us? So let's think about it and look at our problem. And from the looks of it, we read it slowly. I think, yeah, Mariah, you read it earlier for points, but I'm gonna go through it slowly with us. So that'll be, it's rotating. So the windmill, I know y'all seen windmills before. Some of y'all yesterday said that. You've been on a farm, you see a windmill. It's like a nice little structure with a fan type turning about it. And the same thing is also true with turbines, wind turbines. That's a metallic windmill, right? So this is rotating at 3.54 radians per second. That's your angular speed, anything like that, right? So the rotational speed. So let's write that out. Which one of these variables would it be? Well, I told you, if you see rads per second over here, that's an omega. So what we're going to do is write it out in terms of its components, okay? So we would say that you have omega final is equal to, well, what happens? It's slowing down, right? So it's eventually going to stop. So that'll be 0 rads or radians per second. What about the initial? That's a little different. When we came to the situation, it was already rotating, and that's the initial speed of it, so, or angular speed, I should say, velocity, is 3.54. So that's what it started with, 3.54 rads per second, right? What else did the problem give us? So let's keep looking. Well, you'll notice that the angular acceleration, that's alpha, right? Because it's rads per second squared in the problem. That's what you're looking for. Pay attention to what's after the number so you'll know how to set it up. Well, that looks like it's a negative, and it's only negative because, remember, it's slowing down that rotational speed of the windmill to a complete stop. So that'll be initially negative 65.36. Again, use your Greek letter alpha. AV is a subscript, and it's negative, like I said, 65.36 radians per second. And be careful, this is squared because it's an acceleration. All right, so what is the question asking us? And it said how much time? We can just assume that time is seconds, right? So that's delta t, that's a change in time that we're going to calculate for using our algebra skills to derive that answer. So it's going to be some number we're going to calculate later. That's a question mark. All right, so this is part 2 of your notes, right, before you get to the quiz. And you have a problem in the quiz area of your UDO section. There's one problem. It's just like this, but the numbers change. So make sure you take good notes on this to tackle that problem in the quiz area. So what are we working with? We're going to say, hey, this is part 3 of your notes, by the way, as we're moving on. Please keep it in structured order, because when you're writing a scientific document, the goal is for someone else to be able to replicate your work, understand where you're going, your thought process. So annotate it correctly. We would say step 1 really is only one big step to it. It's just a lot of steps inside of it. We call it a multi-step algebra problem. 2 steps, right? So solve for delta t here, right? And please put that. I see students getting lazy and they're just putting all these different things. Label out your steps. There's nothing wrong with being neat with your work. Take pride in your work, right? Don't turn in no garbage. I don't want to give you a garbage answer. Garbage grade. So here we go. We're going to take this equation, our tool. I'm going to use, these are 2 forms of it. I'm going to use this form here. I'm going to use this form here, then that form, because I can move this all around easily, right? All right, let's go ahead and do that. When we start off, we have our normal equation of alpha AV is equivalent to, you have delta omega up here over delta t. This is the easiest way to keep it, so when we're moving stuff around algebraically, it doesn't become hard on us, right? So let's continue by writing it again and doing some algebraic surgery on it. Rewriting it. For y'all can copy and paste down one, right? Type it. T. And use a different color here. I want to isolate delta t, so I just use my algebra skills. It's already being divided, so the opposite of division is, of course, multiplication. So let me go ahead and multiply this variable here by itself, so I can, get it out of the denominator. Don't be lazy, like I said in algebra. What you do to one side, you do to the other. So we come over here and multiply it by delta t, right? That allows me to cross something out. Anybody see what that is? I'm trying to give y'all points, but let's see if you even pay attention. You know what crosses out, Miss Booker? You squinting at me, I don't know. Mariah, you know what crosses out? Okay. Okay.
Is it them two right there?
What is them two? You want to come up and point at it if you don't know what it's called? Okay, so what are you pointing at? I'm going to point over here, but I want you to tell me what crosses out here. So, and I got them labeled, what it's called. So that's called seconds, that's called. So,
what's the unit called?
What's the what?
It's the average angular acceleration.
Mm-hmm. That's the equation. Okay.
And then under it, it said negative brackets.
This? Alpha? Over where?
Right there. What's that say?
Delta?
Okay.
So what crosses out?
Is he crossing out the omega and the second?
The what?
The omega and the second?
No, not the omega.
The one crossing out? No.
Delta what?
I don't know what that is.
So again, this is called delta t, right? That's called delta omega, right? So I was trying to get you to say delta t, because you see delta t divided by delta t. You get 5 points for trying that. So this crosses out, I don't know if you see that, right? Delta t divided by delta t is 1. What is Asia divided by Asia equal to? Let's see if she gets it right. No, a lot of students in all of my history of teaching always say their name. I treated you as a variable, right? I said Asia divided by Asia, you said Asia. Students for 8 years have done that. All right, that's a fundamental glitch in mathematics. What is Mariah divided by Mariah equal to? Oh, she got it right. I must have said this yesterday. Did you see what happened there, Asia, or no? I don't know how you got Asia if you're dividing by yourself. So what is A divided by A then? Just testing you out. Oh, you get it now, huh? Yeah, okay. So this is why this goes away here. You can cross cancel it out. I had to do it to my son. He always did it too. I was like, what are you getting at? How are you getting yourself? Anyway, you come down one and rewrite this because these are cross cancel. Remember what you do one side, you do the other side. So now we have a little bit of a different equation, and we still got to isolate delta t using our algebra. All right, so delta t multiplied by, just rewriting without the stuff that's crossed out in the new equation. So it's going to be delta omega here. Not W, it's not a W. Looks like a W, it's a Greek letter called omega. Right? Omega. So use your insert special character, you see what that looks like. Or, like I said, Asia, you can look at your book at 274, because that box was your starter notes for number 1. Just making sure, because I don't see your book open. Trying to help you out so you don't miss it. You don't have to type it like this, right? You just have to type everything in that box on 274. Let me know when you find it so I can make sure you got your first part of your notes. Now the rest of this, yes, you write it right off the board. That part usually comes from the book. Anyway, we're not through. We still got to isolate delta t. Right now, we just got the denominator. So let's go ahead and rock and roll with this. We're gonna come down to iteration. And we're gonna say delta t multiplied by our alpha AV is equivalent to delta omega again, not W, right? So in my chair, whew, this building gets good heat, hot. All right. Okay. I guess it gotta be that way because all that snow outside. So, what are we working with here, right? Well, let's think about it. There's one more step to this. Last time it was being divided. Now we got a multiplication process here. So we gotta pretty much divide that other side off. But what's next to what we don't want? So delta t is the goal. Alpha AV is next to it. We're gonna divide that out on both sides, right? So let's do this. We have alpha AV. And then what you do one side, you gotta do the other, cross out alpha AV because it's divided by itself like last time, right? Turns to 1. Write your new equation, and then before we plug in the numbers, we gotta break down the delta symbol, which is a displacement, final minus initial. I know y'all have done the calculation for slope. Well, what is the calculation for slope? That's m is equal to delta y over delta x. So that's a math symbol that does a lot of stuff. Gotta use it. So anyway, come over here and I'm gonna say my new equation is delta t, finally is by itself, is equal to delta omega divided by your alpha subscript AV. Now, this is the tricky part. You gotta break down the delta omega. Because it's being...
This computer goes in that car.
I don't know.
I only know because of the
They've been swapping my computers.
Yeah, because of the inventory of the file that he had already with his 14. I'm like, I was looking for this one.
Okay. I don't know. Like I said, I've been trying to just maintain them. Anyway, so look, you got delta t is equivalent to not just delta omega. Remember, I told you up there, you have a final and an initial. And the only reason I kept this delta omega is I wanted to move that variable around without having to move all that up there around. WF, omega f minus omega I. That's a lot to move around when you're doing algebra in these steps, right? So now we can break down what is delta doing. We can say omega f minus omega I, because it's final minus initial, that's what the delta means, divided by your alpha AV. Again, that weird little symbol. Type in insert special character alpha, and you will find the Greek letter to use in your document. All right. Now we're ready to plug in our numbers and get this problem over with. So I'm going to come this way with it. We're going to say, hey, for calculating delta t, we need to put in what? Look at your numbers. Now remember, your final speed was when it came to rest or stop, the windmill. So that means it's going to be 0 rads per sec minus what was your final, what was your initial, right? Because you're following this equation. Well, it's going to be 3.54, and that's also rads per second, right? All divided by, what was your acceleration, average acceleration? It's right there. That's why we did this. We got the ingredients out of the cabinet, and now we're cooking the problem mathematically. So let's go ahead and put those numbers in. So parentheses 65.36 rads per second squared, right? So now we can just calculate. You can use your calculators on the desk, or you can use Google to the best of your abilities. So let me hurry up and do this because it's 10:50 and we're gonna change periods to 11:10. So you got 20 minutes. I don't know if I said it to you, Asia. Y'all have until 8 p.m. on Monday, and it's a holiday, so I have to work from home and to do all parts of the quiz. I don't know if you, before you get out of here, you want to get some notes from Mariah, Asia, because I know you've been having trouble getting here, but it's also Mariah to get any notes that you might not have. You'll have at least one of the problems, Asia, in the you do section, because I just changed the numbers. The other two, it was Monday through Thursday when we did them, so you might want to, hey, let me get some notes from you, right? Whatever, work it out. Let's calculate this answer so we can be done with it. If I pull up a tab, I can show you exactly how to type it into your document. If you're confused about how to type all this in, just look at what I do here. I'm not going to put the actual dimensions in because Google doesn't need that. It's going to turn into a search. But you should put it in when you put it in your notes. So usually, to turn Google into a calculator, you would type alpha AV is equal, and that's what the equal sign. If you look at my screen up here, you have approximately, let's do the parentheses. Let me take this because some students can't see that. You have, why is school still open? Girl, sorry. You got equal sign. I got friends talking about why is school still open? Equal sign, I got two equal signs. And then we want to use parentheses here. So we got that 0 minus, right? And then we got 3.54. I know the 0 doesn't matter to some people, right? Close the parentheses. And we're going to divide that by, use some set of parentheses. You got a negative sign there. I don't know if you can see it on the screen there. And so you got parenthesis, negative, and what was it? 65.36. And I'm going to close my parentheses because it's computer science related. For y'all would type the dimensions by these numbers in your document. But I'm showing you how to, in a computer science way, type it where you can still keep the fraction making sense. So use parentheses as best you can. And then what you do is you hit enter, and it yields you a yield like this, right? So technically, this number is in decimal form, but we want to always convert it to something scientific. So I'm going to write it out, and then I'm going to show you how you should write it correctly if you're going to be an engineering student. All right, so look at this. We just saw what the answer was, right? And that's delta T is equal to, it's going to look like 0.0542. Is there a 6 there? Let's do that. So 0, and I'm going to show you why that looks better. So 0, what I'm about to do looks better next step. 5, 4, what do we say, 2, because there's a 6 there. You round it. It's about 4-digit places because I want to do something to it that allows it to be better displayed. This is only seconds now, but we got to convert this over to engineering notation or scientific notation. The easiest is scientific notation because you just need the first real number when you move your decimal. So we're going to move it over, get different colors so you can see that. It's a good technique to know for SATs testing. 1 place, 2 place, 3 place. All right. So now we can write the number as, remember how many places you move. Delta T is equal to. Right. Moved it 3 places so you remember where your decimal stopped at. I want 1, 2, 3. So that'd be 54.2, right? It's kind of engineering notation at this point. And then, well, how many places you move? Times 10. So then -3, because we moved it 3 places, seconds. It's a really small amount of seconds, huh? But that's how they write it. So don't get confused. think -3 is milli or something, so you can say milliseconds. But you know, most people don't know what milli means, so you got to kind of show what milli means. That 10 to -3. All right, I think that's it. I'm done talking. You got 15 minutes to do what you need to do on that quiz. Of course, you have, like I said, until Monday 8 p.m. I know in ESB it says 8 p.m. tonight. That's just what I do to make sure it's uniform. But don't worry if you turn it in late. I'm turning it on Monday at 8 p.m. because it'll still mark as on time. All right, just make sure you finish all parts of the quiz. And Tuesday we will have a new problem, so please finish it on Monday. Don't come in talking about, I didn't finish the quiz, can I? No. You gotta go to the library, go home, do it on your own time. All right, you got homework to do. All right, that's it. I'm going to start.